Here we go. All right. Okay. Are there any questions so far at all? I mean, if not, that's okay. So. Okay. Let's keep going. There we go. So here's an example. Now here I'm telling you to solve this using the quadratic formula, okay? So that's what we're doing here. Now, with the quadratic formula, remember what you really want to do is figure out what your A, B, and C are. Your A is always the leading coefficient. In other words, the coefficient of x squared. So in this case, it's 3. Your B is always the coefficient of x. So in this case, it's 4. Your C is always the constant term, which in this case is minus 4. Remember, you always want to include the negative sign if you're subtracting. Okay, that's what you always want to do. Okay, so that's our standard form, which we already have. Notice also you have to be in standard form. In other words, you have to have the quadratic equal to 0. I mean, if this is not equal to 0, then if you try the quadratic formula, you're not going to get the right answer. But we have it equal to 0, so we can keep going. So here, as I said, A is 3, B is 4, C is negative 4. So what do we do now? We just use the formula. And that's what we're doing here. So you can see I have minus B plus or minus the square root of B squared minus 4AC over 2A. So again, I'm just plugging in numbers here for A, B, and C. Okay. Negative 4, that's B is 4, so we have negative 4, plus or minus. We have a square root here. 4 squared minus 4 times 3 times negative 4 over 6. 2 times 3 is 6. So we have all this. Notice here what's nice is 16 plus 48 is 64. 64 is a perfect square, namely 64 is 8 squared. So the square root of 64 becomes 8. We actually have two solutions here because of that plus or minus. Okay, if we have plus, then we get x equals negative 4 plus 8, which is 4 over 6, which you can reduce to 2/3. I mean, with me at least, since I didn't really go into fractions, if you leave it as 4 over 6, that's fine. You know, you don't have to simplify unless I ask you to. And generally, I will not ask you to. So this is one solution. We get a fraction. The other solution we get is this. Negative 2. Again, this is when instead of addition, we have subtraction. And that's what we get here. Okay, so that's the first example with the quadratic formula. Well, that was so much fun. Let's do another one. So we have this one now. Okay. So here, okay, again, it's just like before. We're in standard form, right? That's what we want. We have this equal to 0. Okay. We have to figure out what A, B, and C are. I know you could probably get this by factoring easily, but again, I want to demonstrate the quadratic formula. But here we can see that A is 1, B is 6, C is 9. Okay, as you can see, we're doing this. Right, so again, A is the leading coefficient, which is the coefficient of x squared. If it's not there, right, but the variable is, A is then it's understood to be 1. Right? So if the term is there, but the coefficient is not listed, the coefficient is 1 by convention. B we have is 6. C we have is 9. Okay. Good. Okay, so now we have our formula, and we're going to use our formula. Negative B, right? Negative 6 plus or minus square root of B squared, that's 6 squared, right? Minus 4 times A times C. right? That's 1 times 9 over 2 times a. So here we have -6 plus or minus square root of 6 squared minus 4 times 1 times 9, which is this, all over 2. And notice here that the radicand is 36 minus 36, which is 0. Square root of 0 is just 0, right? So we really have -6 plus or minus 0 over 2, which is the same as this, which of course is -3. So here, this is an example where we only have one solution, right? We only have one solution. Before, this radicand, this b squared minus 4ac, it was positive. And because of that, we got two solutions in the previous example. Whereas here, that b squared minus 4ac stuff is 0. We got only one solution. Excuse me, I'm not done with that yet. Okay, so that's an example, which is fun. Now, I want to do another one. This one. Now notice, you don't want to dive into the quadratic formula yet. Now, why is that? Well, we don't have standard form here. We don't have the equation in standard form. This is a quadratic equation. I mean, hopefully you can just see visually that if you add 5 to both sides, you have a polynomial of degree 2 on the left equal to 0 on the right. But we can't use the quadratic formula yet. Again, it has to be in standard form. So that's why I'm doing this. We get that we want to add 5 to both sides because we want the right-hand side to be 0. And this is what we're doing. And so what we get is this. Now it's in standard form. Right? We have a quadratic on the left equal to 0. Okay, so again, we have to get A, B, and C. A, right, is 1. B is 3. C is 5. Once you get that, what do? Quadratic formula, like so. We have -b, -3, plus or minus b squared, right? B is 3, 3 squared, minus 4 times 1 times 5, 4 times 1 times 5, all over 2 times a, 2 times 1, okay? Notice here that the radicand is 9 minus 20. In other words, we have a negative number here. We're taking the square root of -11. Well, you can't take the square root of a negative number, right? Since we're not dealing with complex numbers. We're only focusing on real numbers. In other words, this is not a real number. So what does that tell us? That tells us there are no real solutions to this equation. Oh, wait. I wrote that out in words, but I didn't. So there are no real solutions to this equation. Because again, what's under that radical here is negative. You know, we don't take the square root of a negative number. Okay. So going back to the 3 examples, right? We saw that if b squared minus 4ac, if that were positive, as in the first one, right? We get 2 solutions, right? If it's 0, as in the second example, we get only 1 solution. If it's negative here, we get no solutions. Well, that b squared minus 4ac is pretty important, right? Because of that, we give it its own term. Namely, we call it the discriminant of a quadratic. That's the discriminant. And that determines the nature of the solutions. It also has graphical implications as well, as we'll see later on. So it does have implications with graphing and with finding and with solving the quadratic equation, the corresponding one. Namely, we have this. It tells us how many real solutions there are. Excuse me, how many solutions there are. Okay? And again, since we're not dealing with complex numbers, when it's negative, this has no real solutions. Complex numbers come from when you take the square root of a negative. So, okay. All right, so that's an example. Okay, let me do another one. We're going to solve this one using the quadratic formula. Then I was going to post some and let you guys try some out on your own. Okay, so to get the class engaged. So we have this one here. What's nice is this is already in standard form, right? Okay, because we have a quadratic equal to 0. Our a is 1, as you can see. Our b is 2. C is minus 1. Remember, you want to include that negative sign when you're subtracting. Otherwise, your answer is going to be wrong. So we're using the quadratic formula, like so. Right? This is our formula. I'm replacing a, b, and c in their right positions, as you can see. b, we got negative 2. Square root of b squared is 2 squared. Minus 4 times 1 times negative 1. Okay? Minus a negative, that's why we get addition here. You know, it's really 4 minus minus 4, but 2 minuses give us a plus. So we have 4 plus 4, as you can see. So what we get is we get 2 solutions, negative 2 plus or minus the square root of 8 over 2. Now, technically this is right, but we can keep going. Let's simplify this thing. Right? We learned how to do that. Remember what you do is you want to radical 8, right? I think we saw it as not simplified. And to simplify it, you have to factor out a factor that's a perfect square besides 1. So we know 8 is 4 times 2, right? Again, radical 8 is not simplified because 8 has a factor besides 1 that's a perfect square, right? In this case, it's 4. So we factor out 4, then we take square roots. Square root of 4 is 2, as you can see. Right? Basically, what I'm using here is square root of a product is the product of the square roots. And so if I substitute, this is what I'm getting. All I'm doing here is I'm, in a sense, writing this in a different but equivalent way, like so. And then I'm just canceling. So we get negative 1 plus or minus radical 2. Okay. And that's our, those are our solutions. Okay, now, let me just pause this.